So in this video, I'm going to cover some tips and tricks for simplifying some different algebraic expressions. Now, there's no way I could ever show you an example of every type of simplifying you could ever be asked to do. You really just have to know your rules and what you're allowed to do and what you're not allowed to do. But these examples should cover some things that you're going to see pretty frequently, some types of problems. And also in this video, we'll refresh you on the idea of rationalizing, which is something that you have to do sometimes in order to simplify expressions. So I'm really just focused on these first four bullet points here, first 4 bullet points, excuse me. Okay. So my issue with this first one, I could go through and do a bunch of distributing, but then I'm going to have a bunch of terms that I can't get rid of. And what I really want to remind you of is when you're living within a big fraction like this, we can't cancel pieces that are connected with addition. So I can't start canceling any of this with any of this stuff down here with all these plus signs in between. Okay. Now, I'm seeing something here that I like, but I can't just go start crossing things out as long as I've got this plus sign here. So what I'm going to do is I'm going to take this thing back apart, which is a shame because somebody probably worked hard to put these together with like a common denominator or something. So what I'm going to do is I'm going to separate this fraction. Let's see. I'm going to put this together as 1. And I'm going to put this together as 1. So we're allowed to create 2 separate fractions. They just both have to have this denominator. Okay? So I'm going to write this like this. 2 times x plus 1 over the denominator of 9x plus 1 plus 3 times x plus 4 over 9 times x plus 1. Okay, so let's look at what that allows us to do now. Now I've created 2 separate fractions, so I'm not dealing with one big fraction, and now I can think about how does this simplify and how does this simplify. And the reason that's important is if I look in this first fraction, these 2 things are being multiplied together and these 2 things are being multiplied together. And when things are multiplied, I'm allowed to like start canceling some things out. I can get rid of this x plus 1 with this x plus 1, and then I'm left with just the 2 over 9 here. Okay, so I'm going to write that down as part of my final answer. Plus, now I'm going to look at that other fraction. Now, in the other fraction, I can't do it. So we know these parentheses don't match like they did over here. I can't wipe out this x with this x because these are part of an addition problem. So this is all one thing and this is all one thing and they're not the same thing. So they can't cancel with each other. What I do see that I could do is I could work with the 3 and the 9 out front. And I can't cancel them completely, but 3 over 9 we know reduces at least a little bit. So as part of my final answer, I'm going to turn this into a 1/3 instead of a 3 over 9. And then my fractions or my parentheses are going to stay the same. So x plus 4 here and x plus 1 here. And you might be looking at that and saying like, well, we didn't really do much to actually simplify it. If anything, we made it look kind of gross. But in terms of what our goal is going to be as we're doing calculus with this, what's written there in purple is preferable because we were able to cancel out that parenthesis x plus 1. But we couldn't do that without separating the fraction. Okay, so looking at this second one, I'm reminded that as we're multiplying fractions together, what we really need is a common denominator. Okay, and these are really close to being a common denominator, a minus b and b minus a, but they're not exactly the same. So I want to show you a trick that you could do with this. I'm going to take this fraction over here on the right, and I'm going to multiply top and bottom by -1. And I want to show you what that's going to do. So if I do that, let me just rewrite what I have now. My first fraction is staying the same. So this is 5 over a minus b plus. Now my second fraction is -1 times 7 on the top. So I have a -7 here now. And on the bottom, if I distribute this negative, I really have this, negative b And then my a was negative before, so when I multiply it by -1, I have positive a. But hold on a second. If I take that, negative b over a, that's really the same thing as a minus b. Hopefully that makes sense, that negative b plus a is the same thing as a minus b. So me multiplying by that -1 made it so that now I have common denominators. And so now what I can say as my final answer is I can add together the numerators. So 5 plus -7 is -2. And then my common denominator is a minus b. And that's my final answer. Okay, so now when I'm looking at this next one, the next one, so once again, I want to remind you, I can't just go crazy and start canceling out these square roots because they're attached with addition and subtraction. So this is all one term that would have to be canceled with something that looks exactly the same. And same thing here. So I can't cancel anything. My real issue here is we can't let square roots live on the bottom of fractions. Okay, that's the piece of this that needs to be simplified. And so what I'm going to do is I'm going to use, and I mentioned this in the first video if you watch that one on factoring, I'm going to use something called the conjugate. Okay, so on the bottom, I'm going to multiply by almost the exact same thing, a 3 and a square root of 5, except this time I'm going to put a minus sign in between, and I'll show you why I'm doing that in just a minute. But we're only allowed to do this if we do the exact same thing up on the top, because just like we did right up above, like with this -1 over -1, I'm allowed to do that because this thing is equal to 1. So this thing that I wrote here in red is equal to 1, and multiplying by 1 doesn't change anything. So on the top, we're going to have to do some like FOIL, some distributive properties. So I'm going to go 7 times 3. Let's see. I don't know if this is going to be my final answer or not, so we'll find out. So 7 times 3 is 21. And then I'm going to go 7 times negative square root of 5. So that's going to leave me with -7 square root of 5. I'm just going to leave it like that for now. Then I'm going to do negative square root of 5 times 3, which gives me -3 square root of 5. And then last, I'm doing negative square root of 5 times negative square root of 5. Well, negative and negative are going to make a positive. Oops, I want to blue over here. And then square root of 5 times square root of 5, this is the important part, that when I do a square root times a square root, really what I'm doing is squaring a square root, so the square root cancels, and I'm left with just the number underneath. So square root of 5 times square root of 5 leaves me with just a 5. You may also think about that as like square root of 5 times square root of 5 leaves you with square root of 25, and square root of 25 is just 5. Okay, now we're going to do the same thing on the bottom. 3 times 3 is 9. Okay. 3 times negative square root of 5 is -3 square root of 5. In the middle here, square root of 5 times 3 is a positive, oh, I did it again, +3 square root of 5. And then here at the end, square root of 5 times negative square root of 5. Well, first of all, I've got a positive times a negative, so I know that this is going to be a negative. And then just like on top, when I do square root of 5 times square root of 5, that leaves me with just a 5. Okay, here's the really critical part here, and here's where this idea of a conjugate comes into play. The conjugate, again, just to remind you, is like this was positive, so I did the exact same thing with a negative here. And that whole positive negative idea is what makes this happen right here. This is going to happen every single time, okay? And I just want to make sure you're seeing it, that what I'm left with here, oh, my highlighter tool is not quite working, is always a positive and a negative of the same thing, which means those are going to cancel out, right? That when I have positive and negative square root of 3 square root of 5, they cancel. And with a conjugate, that should happen every single time. Okay, you will always have that situation. So now if I clean the rest of this up, because remember on the bottom is really where I wanted things to cancel. That's why I did the conjugate on the bottom. If I clean the rest of this up, on the top, I've got a 21 plus 5, so that's going to leave me with 26. And these ones I'm just going to combine like terms. So I'm going to say I have a -7 and a -3. So that gives me a -10 square root of 5. And on the bottom here, I'm going to put together the 9 minus 5 and get 4. But then these terms canceled. And that's what I wanted to have happen, right? And so this over here that I'm left with is a more simplified version because I don't have any square roots living on the bottom. And that's what I was trying to avoid. Okay, that was a long one. The last one I think is actually easier than this one. The last one we do run into the same problem with having a square root on the bottom, but because it's only a single term, it's just the 1 square root of 10 there. I don't have to go fancy with like conjugates and FOIL and all of that. I can just multiply by another square root of 10. So I'm going to multiply by a square root of 10 on top and bottom. And again, you'll notice that this fraction that I wrote in red in the last 3 problems, this one and this one and this one, are all just fancy ways of multiplying by 1. Okay? And so here's what I'm going to be left with. On top, this will have to distribute. Like I do have to multiply this by both. So I'm going to have -8 square root of 10 plus, and then here, this is going to be like 11 times the square root of 10 times another square root of 10. And if you remember up above what we talked about, when I do this, square root of 10 times square root of 10, that really makes just a 10. Okay? So in a second, when I clean this up, I just want you to keep that in mind, that this is really like 11 times 10. On the bottom, when I do square root of 10 times square root of 10, that leaves me again with just a 10. So let's clean this up for a final answer here. And up on top, I'm going to put the 110 first, just because we usually put the whole numbers first. So I'm going to put 110 minus 8 square root of 10. And then on the bottom, I'm going to put just a 10. Now, an argument could be made that we could do something similar to what we did up here in number 1, and I could like simplify the 110 over 10 and the 8 over 10. In terms of what we're doing in calculus, to just reduce a fraction, it's not really worth the trouble. Up here, it was important that we did that because we were canceling out a parenthesis, which you're going to see eventually means that we're canceling out a discontinuity. And that's why that was important there, but I'm not going to stress about that with this last problem. Okay, so that's it for these examples. And again, you may encounter some other simplifying type things that you have to do. We really just have to know all of our pre-algebra rules. But if you run into anything that you're not sure about, I'm sure we will continue to talk about it.